Welcome to Study Loop.
So we're given a lot of values related to two satellites orbiting a planet. So for the first satellite, we're given its orbital velocity and we're given its orbital radius. And the second satellite, we are given its orbital radius, and then we're asked to find what its orbital velocity is. We're given a lot of other information too. We're given the masses of these two satellites. We're also given the radius of the planet itself. So this seems like a lot, and it's probably going to be more than we need. And in fact, if we remember back in problem 21, we even found that the mass of the satellite has nothing to do with the velocity of the orbit or the radius of its orbit. So there's definitely more than we need, in fact. So let's just kind of start working this and see what we do end up needing. So a good place to start is this equation for the velocity of circular orbit because it relates a lot of these variables here. So we know the velocity is going to be the square root of the gravitational constant times the mass of the planet divided by the orbital distance, the radius. So we can apply this to the first satellite, so V1 and R1, and then let's think about how we would apply this to the second one. So V2, which is what we're trying to find, equals G mass of the planet over R2. So we know everything to solve for this except the mass of the planet here. We know G and we know R2. So if we have the mass of the planet, we'll be able to solve this. So hopefully then, from the information they've given us about the first satellite, we can find what that will be. And in fact, we know velocity, we know radius, so we should be able to just solve for the mass of the planet here. So doing that, we square both sides and multiply by r divided by g, and we should get the mass of the planet is v1 squared times r1 over g. And so now we can just take this and plug it into the second equation here. So we now have square root of g times v1 squared r1 over g, and then this was divided by r2. So the g's cancel out, so the gravitational constant doesn't actually matter here. And then we are left with just the square root of v1 squared, which we're given, r1, which we're given, and then divided by r2, which we're given. So we can now evaluate that. And when we do, we should get that it is 7,330 meters per second.